So the objectives of this program, as I said, it's basically sharing what we all know. It's sharing about mixing technology, it's sharing about the processes, it's discussing the best practices that we have in this field. So we would go through all of that. We will have some case studies. We will look at different equipment. We will look at theory concepts, and yes, we do have participation from different aspects. So we have from research and development. We have process engineers. We have project engineers. So it's this diverse participation is because mixing as a field is applicable everywhere. There is chemicals need mixing, pharmaceuticals need mixing, food products need mixing, and there could be no end to the applications that you can have, to the processes that you can have, to the materials that you can have. It can be very, very diverse. So we have chemical industry, food, pharmaceutical. Our objective in the industry today is to create better products at lower costs through improvements in mixing systems. And another very, very important thing, this is what we might believe, no matter how good you are, you can always get better. So this is the focus with which we will start the program. Because all of us will bring some expertise, but there is always an opportunity to learn more. The contents as we progress during these 2 days, so we will talk about liquid mixing, solid mixing and high viscosity mixing. When we talk about these topics, we will look at both the theoretical concepts and the equipment, the applications, selection of equipment, advances in mixing technology. We will touch upon computational fluid dynamics and the new technologies which are catalyzing the developments in the field of mixing. Tomorrow we will have a session on mechanical components of mixing equipment, because as much as the process is important, the equipment is equally important. So the components that get into a mixing equipment, besides the mixing elements, what we will discuss tomorrow, and in fact we will have again faculty who would be having the specific experience. So the areas that we would be covering tomorrow is motors, gear reducers, couplings, bearings, mechanical seals, cupping boxes. So we have the participation from the specialists. They would be there with us tomorrow afternoon to take us through each of those sessions. And as we did discuss, we would have a framework on addressing the challenges that we have related to mixing. A course map on how we would proceed, starting from this moment till tomorrow evening. Okay. So we would be covering this whole program in different sections or modules. So the first section that we would start is with introduction to mixing. Okay. We would discuss what is the difference between liquid mixing, solid mixing, and paste mixing or high viscosity mixing. The modes of operation of mixers. So mixers are either batch operation or continuous operation. So we would be touching upon batch and continuous mixing. Scale up of mixing equipment, the broad guidelines which would be relevant to solid, liquid and viscous. When we get into the details, we would realize that each of them would have different criteria for scale up. Design, where we would talk about mechanical design, process design and equipment characteristics. These are the aspects when we talk about mixing equipment we need to look into. After having completed the introductory section, you would then move on to fluid mixing. This is going to be our prime topic as we move on through the day. And we would talk about the different applications of fluid mixing, which would include blending miscible liquids, mixing of immiscible liquids, liquid gas mixing, liquid solid mixing, and fluid motion. These are the areas or the applications in which all liquid mixing applications generally fit into. We would talk about the other important aspects, which is flow characteristics, power required in mixing, mixing regimes. We would discuss aspects related to the equipment design, the different equipments that are used for liquid mixing. So we have top entering mixers, we have side entering mixers, we have jet mixers, we have portable mixers, and we have static mixers. Again, a broad classification. What is most common is what we will get into the details, and that is the top entry mixers, where we will discuss aspects such as vessel design, the different kind of impellers. We would actually do a numerical example, whereby, if we were given a mixing problem, okay, or to design a mixing system, a liquid mixing system, how we would go about doing it, what would be the steps. The process would apply also to solid mixing and paste mixing. The only thing is, mixing of liquids, you will have formulae, you will have certain documented literature which you can refer to. In solid mixing, you have to go by experience, you have to go by what has been done in the laboratory, and then use that as a basis. So the different kind of mixing impellers which are used would be axial, radial, okay, impellers, high shear impellers, and close clearance impellers. So this would be the fluid mixing, which would, as I said, be the important part of today's discussion. Depends at how our program is paced. We would like to go at a pace at which all of us are comfortable. So we'll be flexible with the way we structure our program. Solid blending, that would be the next topic after fluid. So in solid blending, the theory is as important as the equipment. Okay? And it is very important to understand the material characteristics when it comes to solid blending. The mechanisms which are applicable in the case of solid blending, the blend structure, the blending mechanisms, and the fact that unlike liquids, where once you have a homogeneous mass, okay, unless it is an unstable emulsion and can separate out, in solid blending, segregation can happen. So you need to be very careful about the way you are doing your solid blending. We would then get on to the equipment which are used for the solid blending. So we would have different kind of blenders, the tumbler blender, the convective blenders, pneumatic and silo. We will talk about all these blenders, the constructions, and how would we go about selecting, and what scenario, what kind of blender would be suitable for the application. Next, we would move on to high viscosity mixing. Now, high viscosity mixing is nothing but an extension of solid. The only fact is that in solids, when we would be dealing with solid, we would be mainly dealing with free flowing powders, granular powders. And when we are talking about high viscosity materials, it would be more in the paste form. So we would be looking at, again, the difference of the solid mixing and high viscosity mixing are both related to solids, but the mixing mechanisms in the case of high viscosity mixing are very different from what would be there in the case of solids. So we would be looking at the mixing mechanisms. We would be looking at the challenges when it comes to high viscosity mixing, the power requirements, the heat transfer, the kind of equipment that we need. We would be touching upon the batch and the continuous equipment, looking at challenges relating to scale up and equipment design. So this would be high viscosity mixing. In the later half tomorrow, we will be talking about the components that get into mixers in terms of mixer design. So as I mentioned, motors, couplings, seals, variable speed devices, bearings, gearbox, and we would have a team of faculty coming from the industry who would touch upon these topics. Any questions related to program structure or anything which is of interest and seems to be missing here? If there is something, then probably we could accommodate that towards the end of the day. I assume that it should be fine.